11.4 day 2, we're looking at lines and planes in space. We're going to find equations of planes in space. We're going to sketch planes in space, and then find the distance between points and planes in space. Example 4, we're finding an equation of a plane in 3 space. So we need to remember the formula a times x minus x sub 1 plus b times y minus y sub 1 plus c times z minus z sub 1 equals 0. So to find the equation of the plane, we need a point in the plane and a vector that is normal to the plane. So to obtain a normal vector, we're going to use a cross product of vectors u and v. And so let's find the component form of u and v. So to do that, let's label this point P, Q, and R. And so let's just say u is going to be the vector PQ. And so this is going to be the terminal minus the initial. So this is 0, minus 2, 4, minus 1, and 1, minus 1. So u is going to be negative 2, 3, and 0. So v, let's just choose PR, vector PR. So this is going to be negative 2, minus 2, 1, minus 1, and 4, minus 1. And so v is going to be negative 4, 0, and 3. To find the normal vector, we are going to say n equals, n for normal vector, u times v. So this is what we did previously. So we have u and v. So we are going to write I, j, k, and then u gets written first, and so that is negative 2, 3, and 0. And then v is negative 4, 0, and 3. So I like using the diagonal method, so let me write this over. I, negative 2, negative 4, j, 3, and 0. And then so we're going to multiply across and add these together. So that will be 9i plus j times 0 times negative 4 is 0. And then k times negative 2 times 0 is also 0. Then we're going to subtract going up. So this is going to be minus 12k plus 0, or minus 0. Same thing. And then 3 minus 2 times j, that is a negative 6j. So now this minus minus becomes a plus. So I, j, k, we have 9i plus 6j plus 12k. And that is our normal vector. So now this is, so from what we did in the previous lesson, this is A, this is B, and this is C. Then we're going to use a point. And so I'm going to go ahead and use P up here. So we're going to use 2, 1, 1. And so I'm going to label that as our x1, y1, z1. And then now we're going to find the general form of the equation. So we're using this equation up here. So we know that A is 9 times x, and then minus our y value, our x value, which is right here, which is, so it's minus 2, and then plus our b, which is 6, times y, and minus 1, plus our c value, which is 12, times z minus 1, and that equals 0. So now we distribute and simplify. So this is going to be 9x minus 18 plus 6y minus 6 plus 12z minus 12 equals 0. So I have a 9x, I have plus 6y, and a plus 12z. And then we combine the like terms, so negative 18 minus 6 minus 12. So that is a negative 36, and that equals 0. So we could reduce as well. So we can divide everything by 3. And then so when we reduce this one, we get 3x plus 2y plus 3 goes into 12 4 times. And then 3 goes into 36 12 times equals 0. So there is the general form of the equation of the plane passing through these 3 points. So try this example. Find the general form of the equation of the plane passing through the points 1, 0, 5, -1, -2, 9, and 2, 3, 2. If you try this out, you would have found that the normal vector is -6i minus 2j minus 4k. Then you plug it into the equation. And so you would get -6x plus 6 minus 2y minus 4z plus 20 equals 0. And then simplifying that, you would get this here in the purple, -6x minus 2y minus 4z plus 26 equals 0. And we could multiply by -1/3 or divide by -3. So you would get 3x plus y plus 2z minus 13 equals 0.